massive construction project is underway in Qatar to build a new airport to meet the rapid growth in air traffic that has resulted from the country's economic boom. The new airport is being built in phases on a 22-kilometer square site adjacent to Doha's existing airport, with half the site being on reclaimed land. In line with the NDIA steering committee strategy in choosing Grade A contractors with an international reputation for the project, Seif Engineering and Contracting, a Saudi-based company with a long track record in prestigious projects built not only in Saudi Arabia but also all over the Middle East, were awarded the package CP15 to build the airport operation facilities.
Seif company, and the full name is Seif Engineering and Contracting Company, is a Saudi-based company, is a very, very big company, one of the biggest in the Middle East and even globally.
I came to the new Doha International Airport, which is our project also, which we are doing it here. And basically I was taking care of all the electromechanical works in this project. And we have 3 electrical engineers and 2 mechanical engineers who is taking care of all the electromechanical work, supervising the subcontractor, because we had one subcontractor who is executing all the electromechanical works in our projects, which is the track and scale. And we are managing and supervising and pushing them to finish the project in time, with the quality, without any accident, all of them.
We are giving high, let's say, caliber and very, very high importance in the quality of the works and to deliver the project on time. To be more specific, the duration of this project was around 2 years. However, due to various changes, we are extend a little, but now at that particular time, which is January 2012, we are at the finishing stages and we are ready to hand over the project to the client.
The project itself consists of 8 critical buildings, 2 sea rescue stations, 4 security checkpoints, 1 employee mosque, and 1 employee canteen.
The buildings are located, as you understand, at the critical and correct location of the project. To be more specific, the 2 sea rescue stations are located at the north end and the south end of the airport. Every building is around 120 square meters. However, the main feature of this sea rescue station is a big boat ramp, and the aim of the boat ramp is to launch a boat in the unlikely possibility of an accident and an airplane going to the sea. other four security checkpoints are again located at important points to check the internal traffic and the internal also manpower going around in the airport. Every security checkpoint is around 350 square meters each, and it is equipped with the state-of-the-art security features to control the traffic and to control also all the manpower going to the critical and sensitive parts of the airport.
High quality and safety is the mission of Seif company. The main target of this project is to have zero time accidents by looking and following up all necessary precautions. Through their work, Seif try very hard to achieve high quality and high standard of work. From the beginning, the emphasis of Seif has been on quality, efficiency, customer satisfaction, and long-term planning. This philosophy has enabled the major companies of Seif Group to become among the top firms in their lines of business.
We have also one canteen and one mosque. The mosque, I have to say that it is of contemporary and modern design, and can accommodate maybe around 300 to 400 workers. And again, it is state-of-the-art, of the high quality, observing all the Islamic values. The canteen is consists of a two-story building, and it is around 3,000 square meters total. And again, it is equipped with state-of-the-art cooking facilities and also serving area, and can accommodate between around 200 workers at any time. This building again is located at the center of the airport and strategically located, and can accommodate a lot of workers to meet the needs of feeding them.
All the buildings have a specific construction. The 2 rescue stations and the 4 security checkpoints have canopies which cover the building, giving protection for the buildings against the elements. The skin of the building is metal cladding, which is also covering the concrete structure and blockwork walls. This type of construction maintains high quality and high insulation of the project. All the buildings are strategically located and they have access to main roads, yet they are equipped with state-of-the-art security measures.
Actually, we have the air conditioning system, air conditioning, ventilation and cooling system, which is basically provided by the VRV unit, which is the AC unit, which is cooling the building. And then we have the fresh air unit, which is supplying to the fresh air to the building. And then we have the extract system, which is extracting the contaminated air from the toilet and the bathroom area, and the kitchen also we have.
The above systems were installed at both the sea rescue stations and the 4 checkpoints, using the VRV units as their air conditioning and ventilation systems.
In the mosque building, we have the HVAC system supplied by the package air conditioning unit, and that the package unit is installed in the roof, and it is connected by the ductwork inside the room, and the praying area and the hall and the ablution area, where we have the ladies ablution area and the gents ablution area. All this supplied by the cold air, and this package unit also controlled by the thermostat, which is installed inside the prayer area. We have the exhaust system and the supply air system also supplying to this building. The exhaust usually is installed in the ablution and the toilet area in the mosque, and this supply air is installed also, which will be supplying to compensate the air which is exhausted by the exhaust air.
There is the water supply and the drainage system. The water supply, coming from the main network station, is supplying water stream to the buildings, and the drainage system is connected to the main network system.
We have the plumbing system in this building, which is again classified as the water supply and the drainage system. The water supply, we have the hot water and the cold water system. The hot water is supplied through the water heater which is installed inside the building. The cold water is supplied from the main network system. This water is coming from the other CP, which is the main network, which is CP13, which is supplying the water. When it enters to the building, we have the electronic water meter monitor the water quantity, and we have the pressure reducing valve, which will reduce the main pressure to the required pressure to the buildings. And then this water is basically used in the toilet and the kitchen area. And then we have the drainage system also from the toilet and the kitchen area, which is connected to the main network system. But in case of the sea rescue station, we have 2 separate big holding tanks, which is collected basically all the drainage waters there. And then in the later stage, client intend to collect from the tanker to dispose all the drainage systems.
The main chilled water system is installed in the canteen. This system consists of the chillers, air handling units, fan coil units, fresh air units, and exhaust fans. All of these items are installed in the 2nd floor. The technical room, which has a separate handling unit, is installed in the first floor. The chiller unit is installed on the roof. These chillers and air handling units are basically an automated system which is a part of a BMS, building management system.
The cooling requirement is 24 degrees centigrade, this is the cooling, and relative humidity is 50 degree. In order to achieve this cooling requirement, we are using the variable refrigerant volume split units, which will be installed on the roof, and we have the cooling unit inside each room, and each room is controlled by its own thermostat, which is inside. Whatever the temperature you need to set them, you can set it individually in the rooms, and then each unit is supplied with the fresh air, okay, so that you will have the good quality of the air inside the building. So simultaneously we are extracting the air from the kitchen and the toilet area to compensate the air balancing system in the building.
The firefighting system consists of fire hose cabinets, sprinkler system, the wet suppression system, the exhaust hood kitchens, and fire extinguishers for all the buildings.
We have the special suppression system which will be installed there, and it is installed by the local representatives Ansul system. During the fire, the fire will suppress the complete fire in the kitchen equipment, mainly in the cooking hot meal area. And then we have the fire extinguisher in all the technical rooms. It will be installed like in the electrical room, in the technical room, in the mechanical rooms, and in the kitchen also all the fire extinguisher is installed. And then we have the other special system which is installed, FM200, which is installed inside the ULV room, which will be taking care of all the sophisticated equipment to suppress the fire in the building.
BMS, Building Management System. FAS, Fire Alarm System. VSS, Video Surveillance System. ACS, Access Control System. ULV, Ultra Low Voltage Racks. The BMS system monitors and controls the electromechanical systems, the VRV units, the electrical panels, water meters, the energy meters, exhaust fans, and fresh air fans in the sea rescue stations. The fire alarm system is interconnected to the LAN system, which is controlled by the central fire alarm station building installed by CP31. Video surveillance system is installed in each building. It monitors the external and the internal activity of the buildings. There are two types of cameras. One is the fixed camera and the second is the PTZ cameras, which is controlled through the network system by the CP31 in each building. There are two types of access control system. One is biometric system by the thumb, which is used just for the technical rooms, and the other access control style is the card swapping system.
Our scope of work is we have provided all the passive components. The active component is installed by the CP31, and then again it was tested by the CP31 through the area network session. And then this access control system, if somebody wants to access or forcibly from the outside, then we have the sounder which will give the sound to alert the people that there is somebody is misusing or somebody is trying to open the door. So there will be sounder is available, and it is communicated to the main network system also.
All the above control systems are going through the ultra-low voltage panels, and it will be transmitting to CP31 to monitor all buildings through the ULV racks. Seif constructed the buildings that house all the operational activities needed to keep the airport in operation. In comparison with other major airports around the world, it will be one of the largest and sophisticated airports in the world.
We have a separate annex building in the employee canteen that is called switchgear room, where we are getting the main switchboard, and the transformer room is installed to supplying the power to our employee canteen and the employee mask area. So this building is constructed by us, but all the electrical equipment at the high voltage side, like the transformer and the high voltage switchgear, is installed by the CP13. And then we are getting the power from the CP13 from switchgear room to our main distribution panel, the main MDB room, which is installed our building. And then we are getting the power from the main distribution board to the sub main distribution board. From there, power is fed to the individual control unit, which is supplying to the equipment. The main distribution panel will be supplying the power to the all the small distribution panel inside our building, which we call it is the SMDB, and EMDB is the sub main distribution panel. EMDB is the emergency main distribution panel. We have the two type of power which is available, is the main power and the emergency power. The main power supply will be usually provided during the normal operation. If the emergency power, it will be supplied during, in case of there is no power, the emergency power will come on, and then during that only the essential equipment will be connected to this load. So we have the backup generator in the main building, in the canteen building, which will be serving during the emergency case. So when there is a power off, the generator will start, and then we are getting the power from the generator, which will be supplying to the canteen building, and then this power is transferred to the manual transfer switch, which is installed in the generator room. As far as the electrical is concerned, we have the lighting system, and we have the main breaker, circuit breaker, all the sub main distribution which is available there.
Due to the high quality of the building, Seif had to employ a lot of high qualified workers and technicians in order to achieve the high quality. At the peak of the construction, Seif with their also subcontractors, we employ around 1,000 personnel. One also of the main challenges which we are facing is the coordination of all the subcontractors. Because the buildings, they are consisted of a lot of systems and a lot of constructions, different disciplines, and we have to coordinate all these subcontractors. And at that time, we have to coordinate around 25 subcontractors of various disciplines, civil, electromechanical, and architectural, and all. I would like also to inform you about the challenges which we are facing regarding constructing this project. This project is a small part of a very, very big and prestigious new Doha International Airport. The main challenges which we are facing is the high quality of the material and the long lead items, because these materials they were unique, and we have chosen the highest standards. One of the main challenges which we are facing is the interface with the other contractors. Since this is a small part, as you understand, the challenge was that our buildings has to be worked in complete connection with all the other parts of the airport. And that was a really big challenge because, for example, we have to take care that all our specifically electromechanical equipment must be of the same brand name with the others to avoid the client having maintenance difficulty and also having logistic problems to maintain all this equipment. The other one which also we have to face was that we had to have a high quality without also jeopardizing the high cost of the building.
Qatar is growing day after day, achieving the mission by making safety and perfection first priority, and that is upgrading the country's competitiveness and making it a center of excellence.
As you know, this project was of the very high safety standards, and I am glad to inform that Seif worked very hard to achieve the standard requires, and as a result we took a lot of awards from the client and the engineer. We have employed specialized safety people in order to avoid any accident, and I'm glad to inform you that we have succeeded in this task.
And it is a pleasure to work with one of the world's largest and sophisticated airport project, which has been built by, we are one of the part of that building this airport, and it is really a pleasure to working with this project. And then it is really, Qatar is a good place to work, and it's a very nice city, nice and clean city, and it's the people are good people to deal with them. And then I have been working last 7-8 years in this Qatar. It's one of the beautiful country. I worked with all of them compared to the other countries, and it's nice to work in Qatar. And future, hopefully, then we have a lot of projects is going to come, and then hopefully we are working in this one.
Qatar is undergoing an unprecedented transformation. It is a country on the move and is rapidly becoming one of the most dynamic political and economic centers in the world. With eyes firmly set on the future, Qatar is using its vast energy reserves to realize its economic, social and political potential. The new Doha International Airport is a key project in Qatar's national development strategy. It is designed primarily to deal with the growing volume of traffic at the airport. The airport will be able to handle 29 million annual passengers at its opening, 3 times as many as the current airport capacity. With eyes firmly set on building for the future of this nation, NDIA authorities are setting the pace for a sophisticated airport system through all its high standards and facilities like CP15 that will ensure the vision of its leaders aiming for a promising future.